VDS on and VGS on are given as the values of a MOSFET whenever it is on. VGS is 4 volts and GM is 2000 microsiemens and RS is 1K and RD is 6K. So IDS on is K VGS on minus VGST square, which is from this we will get K as 4 milliamps divided by 8 minus 4 whole square, that is 4 into 10 power minus 3 divided by 16, that is 0.25 milliamps per whole square. After getting K, we have to decide an ID, which is here VG is nothing but 15 into 40 divided by 100, so 6 volts. Now VGS is nothing but 6 minus ID into RS, that is 1K, 6 ID. Now ID is equals to 0.25 6 minus ID minus 4 whole square, which is 4 ID 2 minus ID whole square, which is 4 plus ID square minus 4 ID, that is ID square plus ID square minus 8 ID plus 4 is equals to 0. This is the quadratic equation we are getting. So if we solve this quadratic equation, we will get ID as 7.46 milliamps and 0.53 milliamps. So we have to choose appropriate value out of these two. So if VGS must be greater than VGST, if we choose ID, VGS has to satisfy this. VGS is equals to, so ID from this approximation ID is going to be 0.53 milliamps. So VDS is nothing but 15 minus 0.53 into, that is 7, which is equals to, which we get as from this V0 is equals to 11.3 volts, that is option A is correct. Comes to the voltage gain calculation in the part B. Voltage gain is nothing but minus GMRD, because in case of an AC case, the CS is going to, RS is going to be bypassed by CS, so RS is not going to be influenced in reducing the gain. So it is minus 2000 into 10 power minus 6, RD is 6 into 10 power 3. So minus 2 into 6, which is equals to minus 12, that is, these are all minus 2's, minus. So there is option A is correct. The initial contents of DE and HL page are given as 5472H and 4528H respectively, and all the flags are set initially. So for the following program, we have to find out the following. We have to answer the following questions. The value of the accumulator after the execution of the program, RET. So we have to find out the accumulator content after the execution of the program. Here in the first case, what we are trying to do is we are performing EL addition, and then after we performing DH addition. So after complete addition, we are keeping MVI. Before executing a written instruction, we are loading A with 00. So the accumulator must contain the 00 before means after execution of written instruction. So the data is not going to be affected after written instruction. So option A is correct. Comes to the carry flag is set to. See, after the written instruction, the carry flag is depends upon the last arithmetic instruction before execution of RET. The rotate left carry, rotate accumulator left. So it is here, this is the accumulator content here 1 to 8, because accumulator is an 8-bit register. This is a carry flag. This is D7th bit, D0 bit. RLC instruction keeps the D7 in carry as well as here. So D7 bit, before performing RLC, accumulator contains 00H. So 0 is going to be pushed into the carry before written instruction. So after execution also carry flags are not going to be affected because of written instruction. So option A is correct. Loop transfer function g of s, h of s as k divided by, this is here k, the value of k for which the system is critically damped is here, this one, this 0 and -4. We have to find out the breakaway point. If we are able to find the breakaway point, we can find the k value. So characteristic equation is s square plus 4s plus k equals to 0 minus k equals to s square plus 4s, that is dk by ds is equals to 0, that is 2s plus 4 equals to 0, s equals to -2. This is the breakaway point. We have to find out the value of k, because at this particular point the two poles are going to be identical and it is a critically damped case. K is equals to 2 into 2 divided by 1, that is 4. So option B is correct. Comes to the overdamped case, k 0 to 4 overdamped. At k equals to 4 critically damped, at k greater than 4 underdamped. So option A is correct. Transmission parameters of the network are A, B, C, D respectively. The network is said to be reciprocal if and only if. Here A, D, B, C. C, A, B, C, D. So this is the T network. From this, the reciprocal condition is AD minus BC equals to 1, whereas symmetric condition is A equals to D. That is, this is for reciprocal. This is for symmetrical. That is, option B is correct. Characteristics of an element is shown in figure. The element is, see, the characteristics which are shown in the quadrant 1 as well as quadrant 3 are not equal. Hence, the element is going to be a non-linear. So, the element is going to be active or passive is going to be decided by the V by I ratio. That is, if V by I ratio is less than 0, that is, the element is going to be active. If not, that is, if the ratio is greater than 0, it is going to be a passive. So from this one, this is minus V minus I. So V by I ratio is always positive. Hence the element is going to be passive, as well as it is non-linear element and the unilateral. That is, option D is correct. Across the terminals A and B is, here voltage across the parallel elements is going to be equal. That is, VAB is nothing but a 5 volts here, because the 5 volts is across the current sources also. So option B is correct. The below given circuits, if V1 is equals to V2, both circuits are possible. Hence option A is correct, because in circuit B, this is V1 and this is V2. Whatever may be the V2, this circuit is going to be possible. But in case of circuit A, if V1 and V2 are not equal, circuit A is not going to be possible. But the case given in the question is V1 is equals to V2, hence both circuits are possible. That is, option A is correct.